He is the Senior Manager of Global Business Development for XR and the Product Manager of CloudXR. His team focuses on partnerships and projects that use NVIDIA's professional XR products to bring the benefits of real-time immersive renderings to enterprise environments. Before joining NVIDIA, Dr. Jones was an Associate Director of an academic research institute focused on scientific computing, image analysis, computer graphics, and data visualization at the University of Utah. Welcome, Greg.
Hello, and welcome to this talk on using NVIDIA CloudXR for the delivery of AR over high-performance networks. I'm Greg Jones, Product Manager for NVIDIA CloudXR, and I appreciate your time. And thanks for the AWE committee for the invitation. We recently launched version 1.0 of CloudXR, which followed our early access program. And in this talk, I will give some insight to what we learned during our early access program and how our early access users influenced the 1.0 SDK. I think it's also important, and maybe a little redundant for this AWE audience, but still important to talk about how XR is being used today, which will motivate why XR streaming technologies like CloudXR are so important for the future of both VR and AR. In the enterprise markets, XR is being used primarily to build immersive experiences that turn increase productivity and deliver better design and training outcomes and enhanced customer experiences. In medical, for instance, better outcomes include faster, more effective training for medical professionals and surgeons approaching complex procedures with a better understanding of the patient's condition. In the end, this leads to a better outcome for patients. In manufacturing, increased productivity comes from more efficient assembly processes, faster worker training, and less assembly line downtime. In architecture, better outcomes are happier customers who understand what the build will look like and fewer expensive change orders after construction has begun. Over the next couple of slides, I will show two examples, enterprise use cases where users have found value with XR. In this case, we're going to focus on Bell Helicopter. Go ahead and play the video, please. So this is the FCX1 Bell helicopter. And you'll see that it's a virtual design. This helicopter is now real. They manufactured this. In the next clip, this is the helicopter pilot, the test pilot. And he's going to jump into VR. And in VR, he's going to jump into helicopters. So before testing the helicopter, before metal was cut, before anything like that was done, the helicopter actually, the pilot got to test the ergonomics of the Bell helicopter. And by having him test those ergonomics and work with the engineers to adjust the design on the fly, Bell saves significant time. How much? 5 to 7 years down to 6 months. This is what XR in enterprise is all about. Moving straight into a highly value-add AR use case involving the HoloLens 2, we have a system created by Visual Live. As you can see on the site construction, personnel can look at building information management system information, which helps define installations, percentage complete, comparison of as built to be built, and more. Every construction company I have visited over the last couple of years views this use case as an absolute game changer. There is a challenge doing this type of AR that I will touch on in the next few slides, but before I leave this slide, I want to point out to look at the coloring and the lack of shadows in the renderings of the mechanical systems in this particular slide. Shadows, reflections, light in general are important contextual elements of any scene. And I will maintain that AR is about adding context to an environment if it's about anything at all. So we're missing some of the lighting cues in this scene that would be really important for the use case. I want to remind everyone listening that very demanding capabilities like rendering large data sets with photorealism, with shadows and lighting, become paramount in design and manufacturing, marketing and construction. And to offer these capabilities in interactive immersive experiences is a heavy compute load. Comparing XR, for instance, to gaming, we see that rendering two sets of eyes, or a set of eyes at high resolution at 90 frames per second, which is a typical XR workload, is almost 7 times more effort or compute power than rendering a high fidelity game. This need for powerful compute is the reason HMDs and devices are tethered to high-end GPUs. I want to take a second and talk about tethers. Now that we know why they're tethered, I also want to talk about what the tether does. So in this use case, in these 3 use cases I'm showing, that upper left-hand panel is that Bell helicopter example I just showed. That's the engineer looking at the design. And the middle panel is the filming of a Mercedes commercial. And in this case, the Mercedes commercial allowed the producer, director, and camera crew to be in different physical locations. And in the right-hand example is Steven Spielberg directing in a virtual production the Ready Player One movie. Now, all these use cases are tethered, but they also have another thing in common. They would have all been less awkward if they weren't constrained by tethers. We've seen a number of solutions to get rid of the tether, including backpacks and relatively large pucks that hang on pockets or belts. And I would say that these are not as awkward as a tether, but still create some awkwardness. And if it were just awkwardness, that would be tolerable. But what the magic of VR is the fact that VR and AR are a great magic trick. We trick people into believing they're in a different place with real objects like cars, characters, and buildings. And when it works, it's incredible. They can design and create and learn, but every time they feel a tug on their head, it breaks the illusion. For a split second, they lose the illusion and it breaks their concentration. And because of the cord, the tether, they're constrained in where they can go. Architects can't walk around a new building. Instead, they have to teleport, again, breaking the illusion that we've created with VR and AR. While the immersion into data creating the XR illusion is the predominant value added for XR, and being able to work at scale is very important, there's another important value add of XR, and that is the ability to collaborate. Collaboration, whether remote collaboration, especially important given the present work conditions, or on-prem collaboration, is a driving value for XR. The collaborative exploration of a digital model is a critical feature uniquely enabled by XR technologies. Let me play this video. Go ahead and play the video for me. And as you watch these avatars work around or collaborate around in this environment, working together, imagine these in co-located. So let's say an on-prem collaboration, and think of these avatars tethered. And you'll see that not only is it a little comical, but you can imagine a little dangerous even. And even if you look at remote collaboration, the fact that you can't walk around the room because you're tethered and you have to teleport, again, breaks that sense of illusion. So collaboration is really impeded by the tether, especially on-site collaboration. Now, obviously, the handheld devices and the mobile devices, I've got a group of them shown here. They're certainly improving all the time, more and more processing power, longer battery life, but the limitations of these devices are obvious, especially when you think of the size of data sets in enterprise settings and the need for high fidelity, beautiful graphics. There's just not enough compute power to create a truly immersive experience with the all-in-one devices. To guarantee the freedom of immersion, move, create, and collaborate in a beautiful virtual world with large enterprise data sets, we want the best of both worlds. The power of the high-end graphics cards shown on the left of this slide, and the ease and mobility of the all-in-one devices shown on the right hand of the slide. And to add on to that best of both worlds, adding high-end compute to mobile devices, if you look at the future of XR, the XR workload, especially in enterprise, will continue to require increasing compute capabilities. The resolutions are going up for the HMDs, and the phone screens. Refresh rates will continue to increase. Data size consistently goes up, especially when you think of the complexity of CAD models and the move to digital twins. And we need to collaborate in XR. Thus, communication across networks is imperative in the future of enterprise XR. And finally, the workloads to create high-resolution photorealistic scenes at XR refresh rates are ever increasing. Let me focus on this aspect for a second. This middle image shows XR as we often think, AR as we often think of it. This is, of course, Pokemon Go. Everyone knows this. And you can see there's been some shadowing added to the Pokemon. This image on the right is a Rimac. It's one of those electric supercars. This is on a Samsung phone, also an AR device. And this is with CloudXR. And what you can see is the middle picture paints a whole different XR or AR type of vision than the left-hand panel. And what we've done is we've used lighting from the AR device, given that back to the server to render with the correct lighting in the scene. And we've produced a much more contextual image using a CloudXR kind of high-end render. And that contextual rendering, that ability to render with light samples, that's really, you're talking about a high-end GPU on a server and then streaming that rendered image onto the real scene at the AR device. So again, if we're gonna really focus on contextualizing things in our environment through AR, through augmenting that reality, the rendering, the lighting effects, the lighting cues are really important. The need for combining high performance compute with the flexibility of mobile all-in-one devices is the motivation behind CloudXR. We've really worked to focus on a few specific items in generating CloudXR, and that is running expansive VR and AR to multiple professional users at the edge by utilizing our RTX graphics cards and the high bandwidth and low latency of networks like our 5G networks that are up and coming. Using NVIDIA Quadro GPUs to power CloudXR encoding and streaming of graphics to a thin Windows or Android client device, using basically years of experience in building things like GeForce Now and our encoded technology. The scaling of XR is also an important focus of CloudXR, where the performance of the RTX server with NVIDIA's GPU virtualization software, for instance, the Quadro Virtual Workstation, the QVDWS, to securely enable multi-tenant deployments, which is a common requirement among telecommunications and network integrators. Which brings me to the underlying vision of CloudXR. Basically, if we start on the right-hand side of the slide, we have XR clients, whether they're Android devices like the Oculus Quest or the HoloLens 2, or phones or pads, tablets, or even Windows clients driving a thin Windows client driving a Vive Pro or high-resolution headset. You can think of these thin clients as not having enough power to do some of the high-end rendering that we want to. But if we can stream these over the network, whether it be a 5G network, a Wi-Fi network, or what have you, we can stream those from RTX servers with the NVIDIA GPUs in them, and we can stream original XR content. And in this case, with CloudXR, we enable OpenVR applications to stream natively to our CloudXR. And I'll go over the architecture of CloudXR in just a second. We launched CloudXR as an early access program, and you can play this video. And what this video shows is a McLaren Senna rendered on a program, Autodesk's VRED program. And this rendering is happening in a Los Angeles data center, a Verizon data center, and then streaming over the Verizon 5G network to the floor of the Mobile World Congress show in LA. And that device that's being rendered on is a Samsung 5G phone. Now, obviously, this Samsung 5G phone can't render a 30 million polygon automotive model at interactive rates. And so that's the Samsung phone on the convention floor, and you can see great detail, great lighting, and that's all the courtesy of two NVIDIA RTX 6000s rendering in a data center quite remote to the site and streaming over 5G. And on that last point, scaling, I want to mention scaling and the fact that CloudXR works across virtualized GPUs. We've had a couple of partners, VMware and the Grid Factory, early access users that have tested streaming from virtual machines, and we've gotten some interesting results. First off, we can do XR in virtualized environments, which means streaming from the data center from virtual machines. We've even seen most use cases can hold 2 users per RTX 6000, even with relatively heavy rendering platforms. And certainly when you think of what VMware is thinking of doing, it simplifies the use case of streaming VR. In fact, VMware is working on an enterprise VR client that includes CloudXR and gives customers the ability to securely stream PC-based VR applications from a virtual or physical desktop to a mobile XR device. And we can certainly run introductions to VMware if anybody's interested in that. As I mentioned earlier, an important value out of XR is the ability to collaborate. Collaboration, whether remote collaboration, especially important given today's work environment, or on-prem collaborations are extremely important. And being able to stream from your data center to your show floor, manufacturing floor, or what have you, is a critical piece of where VR and AR are going. So let me introduce the architecture of CloudXR. It's basically 3 components. We've taken a VR experience essentially and split it apart into 2 pieces. The server piece running over on the left-hand side and the client piece running over on the right-hand side. The server piece is going to run the application, and a client piece will have the HMD attached or the device attached, or have the actual client within the device. And here I show a Focus Plus and a Samsung handheld, and both of those are running Android clients internally on an internal GPU. In order to split that apart, we created this glue layer so the 2 pieces can talk to one another. On the server side, we have a virtual HMD driver, or let's say VR or XR device driver. The application, the VR application, in this case, it's an OpenVR application, thinks it has a device attached to it, just like it would on a regular PC or laptop. And on the client, we wrote a VR application that accepts and decodes frames and audio and presents them to the user, to the client. And it sends back controller and HMD tracking data as well as inputs. With XR, we also send back from the client lighting information in the form of spherical harmonics to realistically light scenes for AR applications. So the point of this slide, one of the points I want to make with this slide, is when you take this application on the upper left-hand side, that's an OpenVR application. It needs no modification to talk to CloudXR. When we install the CloudXR driver on the server, it actually is an add-on to the Steam VR platform and accepts the frame from the VR application, encodes that frame, transports that frame to a client, which is also an OpenVR application, an OpenVR library, essentially. That library then hands the HMD the frame that was decoded from the stream. We've packaged this architecture into 3 component SD and an SDK. The driver is a binary library that installs on the server and interfaces with OpenVR applications, as I mentioned before. On the client side, we have another binary library that accepts the frame from the server-side library. On top of the client library is a client application. The client application is device-specific. Since we couldn't possibly support the myriad devices that are already and are constantly being released and updated, we've supplied a sample client application and source code. Essentially the SDK part of the CloudXR platform. Device manufacturers can use our sample code to build device-specific client applications. So CloudXR can support just about any device as long as someone's willing to write the APK. If we dive underneath the surface of the server and client, here's the engineering view. The VR application doesn't know anything about CloudXR. This is really important. Existing OpenVR applications just work with CloudXR. Developers don't need to do anything to their applications. CloudXR comes in with its own VR runtime, which knows how to communicate over the network. And similarly, on the client side, it works with existing HMDs, no special hardware required. So the application runs on the server. It thinks it's directly connected to the HMD, but really the HMD is on the other end of the network on the client side. The network layer between the server and client manages all the traffic, sending the images and audio from the server to the client and sending the controller and HMD tracking data from the client to the server. It handles all of the compression and decompression and all of the complexity of dealing with the network, especially the quality of service type of dynamics. That last part is really what makes streaming XR challenging. Networks are unpredictable, and for XR streaming to be successful, we have to build a bunch of technology to guarantee a smooth experience despite any network challenges that arise. Here's an image of measured network traffic. As you can see, the network performance is constantly fluctuating. In practice, different packets take different paths between the client and server, so some will arrive out of order, some will arrive faster than others, and some will never arrive at all. We need to be robust to all these conditions in order to deliver the best quality of service experience possible. Below are some of the challenges associated with delivering high quality service over the network. We've been addressing these challenges for a number of years in our GeForce Now streaming architecture and our encoder work. For each challenge, we've implemented a solution that has parameters exposed that when we tune in real time during the XR experience. There's a lot going on here. I just want to point out a couple of the challenges. We're constantly monitoring the bandwidth over the network. As it fluctuates, we use our encoder to adjust compression automatically. There's another, if we miss some packets, we use forward error correction to fill in the blanks. And then most importantly, you look at the topics that we work against here, the challenges. What CloudXR does is provide all these components and it orchestrates them to provide a global optimization that creates a smooth solution to the user, even under very challenging conditions. And it's really critical to understand that the outcome of a smooth experience in VR is not just working with these parameters, but really orchestrating them and finding that global optimization rather than a bunch of local minima. With CloudXR, the idea of streaming XR can work over a variety of different configurations. As shown on the right, we've built support for a number of different AR and VR client devices. Ultimately, our goal is to work with all device manufacturers to implement CloudXR clients through our SDK and our sample code. In the middle, we're showing the network. What we're highlighting here is that the network can be anything, 5G, Ethernet, Wi-Fi, it doesn't matter, as long as it has at least 50 meg per second of bandwidth and less than 20 milliseconds of latency, really ping time latency over the network. And really critically, a minimum of noise. Anything meeting those conditions will work really well and give a pleasant VR experience. And finally, on the left, we have our servers where the application is running and the rendering is being done. This can be an RTX server in a cloud, like at a telco edge, or it can be an RTX server that runs on-prem in a company's data center, or it can even be your own workstation running a room down the hall. CloudXR will run on all of those use cases. And again, as long as the network is 20 milliseconds or less ping time, 50 megabit per second or more, and a minimum of jitter, basically. I want to go over the fact that in the CloudXR 1.0 release, we've enabled OpenVR applications to run AR, and it's a relatively simple piece of work to do. I've lost an image here somehow. Here's my image. This is an example, as I showed earlier, this is an example of AR being run with CloudXR on a Samsung phone. And it's important to know how to do this. This is in the documentation that comes with CloudXR. To stream CloudXR, you need to expose the RGBA, the alpha channel in your VR application. The alpha channel shows the regions to CloudXR where the live camera content will be overlaid on the real scene, and device like ignore the right eye data. But because OpenVR requires the submission of both eyes for optimal performance, we recommend the application also submits the left eye texture as a right eye texture by using the same texture or a dummy texture. But basically, it's that easy to turn an OpenVR application into an AR string application. We've got a couple users, a couple partners, really is a better way to say it, that have worked with CloudXR and have created these types of applications. This particular one is Keyshot. Go ahead and play the video for me. Keyshot has created their Key VR application, which is a one-click VR application from the Keyshot rendering program. And this is a CAD to render. And you can see this is the AR application running. So they've exposed that alpha channel and occluded the right eye. And you can see a beautiful AR program with very little effort. Now they're gonna throw this into a real environment, and they're running this on a smartphone. And that's Key VR. And obviously an OpenVR application that has just been turned into an AR streaming application. This next slide is done by the group at Pixies, and they have another CAD to VR, CAD to Unity editor directly application. This application renders extremely large models directly to XR. They can collaborate across multiple devices. Go ahead and play this video also, please. In fact, this asset right here is 350 million polygons, and they import it directly into the Unity editor. And it comes with a lot of nice implementations of what you can do with direct CAD, carrying all that metadata, all the caption. And all those uses, all those capabilities of that OpenVR application are exposed in CloudXR as a streaming application. You can see the CAD lines and such in this case. And then you can even see metadata from the CAD file system if you want to explore metadata pieces. So everything is carried forward as an entire data set in this application. You'll see in the next few minutes, here's the cutting plane type of example. And then they'll move this into a collaborative system using both AR and VR components in the collaboration. This model, it's worth adding, it has over 200,000 3D objects in this model. And so you can't imagine rendering that on a handheld device like they're showing right now. That has to be rendered by a server and streamed down. And you can see they're in a collaboration mode. In that far edge of the picture, you can see a headset moving around. And that's an Oculus Quest, I believe. And that's the Pixies group. So one other collaborator I wanted to show work of, and I'll move to the next slide, is from ESI. And go ahead and play this video for me, please. ESI and their ICI-DO, and they're rendering over 70 million triangles. What they're showing is they're able to take two different headsets, create a collaborative environment. This is an on-prem collaboration. They clear some space. They calibrate the system using that mat. And then they take to set up the system on their iPad or handheld tablet, and then stand on the calibration dot, and they're in VR or AR. This particular demo focuses on a collaborative VR solution. That model, again, is over 70 million polygons. And you can see the two gentlemen discussing and walking over a relatively high resolution model, and with really nice photorealism to it. We had a number of partners work with us. I'll go on to the next slide. This is a little logo garden of the various partners. We really appreciate their help and such. And I would like to say thanks to all the partners for providing critical feedback that really influenced our 1.0 release. Over the next few months, we will continue to show new work for the assortments of groups using streaming XR in important new ways to design, create, and learn. I want to close this talk out by saying thanks for listening. And for any more information about CloudXR and the 1.0 release and our gated enterprise release on 1.0, feel free to go to our website at nvidia.com/cloudxr or contact me directly at gjones@nvidia.com. And thank you very much for taking the time to listen to this online presentation. And thanks for the recording crew for helping out.
Great. Hi, Greg. So nice to meet you. Thanks for your presentation.
Yeah, same.
So we're going to turn to Q&A right now. We have a few questions that came in through the queue. I would encourage other folks who are listening to ask a question. It's a great opportunity to learn more about NVIDIA's tools here. So with that, let's turn to the questions. We have one from Blake Shores. He asked, can I set this up with my own test equipment, gaming laptop, etc.?
Yeah, as long as your laptop has an RTX or a Turing or Pascal generation graphics card and is VR ready, it should work fine. So absolutely. The hardest part is making sure your Wi-Fi is clean enough to channel XR over, basically.
That's an excellent point. Just right now, my Wi-Fi died. So here we go. Another question from Jan Hoovera. They ask, can it be app hybrid, part of DC graph in device, part in cloud? Because if clients receive just video, partial interaction will be very problematic.
Yeah, so right now the interface to CloudXR is OpenVR. So an OpenVR application basically creates a frame, hands it to our version of SteamVR running on the server. So that interface is defined by that SteamVR runtime. And we have a SteamVR runtime that we run on the server. So OpenVR interface right now, and that is the basis of CloudXR.
Terrific. We have a question from Lassie Lepisto. As the motion to photon latency is one of the key enablers of immersion, how does the E2E performance, for example, motion to photon latency of the platform, how is it checked?
Okay, so we certainly have a report out inside the software that we can watch to see the latency. But the real trick, the elegant piece of CloudXR is the fact that we've taken late latch or synchronous time warp, whichever way you want to call it, that last millisecond transform, we've taken that from the server GPU and put it on the client side GPU. So there's a lot of latency in encode, decode, transport across the network, all the rendering latency, of course, the buffering latency we use for our anti-jitter buffer. All those latencies stack up. So you actually have more than your 20 millisecond motion to photon latency required for XR, just like you do in normal tethered XR. But what we've done is moved late latch over to that client side. And by putting the late latch, the last millisecond transform on the client side, we effectively give you an effective latency of 1 to 3 milliseconds, essentially. So really, it's not a question of how much latency is in the network and all the machinations you do to stream that frame over. It's how we manage the workload and do that late latch at the last millisecond. So we're really dependent on that late latch function.
Great. We have a question from Oren Weitzman. He asked, can a client also be a web browser using something like WebRTC, or must it be a native app/program?
It's a great question. Right now, the clients we offer are limited to Android devices and Windows devices that are looking for a 2-eye solution. For instance, if you look at the way we do AR out of CloudXR right now, we send both eyes. We just occlude one, and then we send an alpha channel in the other eye, and that's how you do the AR piece. So really, we're working primarily with this version of CloudXR on XR APKs, so XR clients. So you can think of a way to write a client to just show a web page, but that would be on the user to do at this point in time.
Great, thanks so much, Greg. Well, more questions are hopefully coming in. Certainly encourage people to use the chat function to inquire, ask Greg. I wanted to ask, you had mentioned about the Bell helicopter use case and how they save 5 to 7 years of development time. And that seems like that is a fantastic example. I wondered, is that the standard? What would you say is an average amount of time that your clients save in development?
It's a great question. I don't know, but and it's not just time savings, but we're seeing a variety of time savings. Let's say we've got a couple construction firms we work with. So everybody keeps this. Bell Helicopter was interesting in the fact that they would openly talk about that data and a competitive advantage they got using XR. Most groups don't talk about how much time they save. They like to keep that inside. But we've worked with a couple construction firms that have carved months to years off their construction. But more importantly than even the time saved is, let's say you have a set of doctors and nurses testing out an operating room before the operating room's built. Typically what happens when you construct a hospital is you build the operating rooms. For the first couple months, people run in them. They do example procedures, and then they file all the changes they want in that room. And you go into the already constructed room with change orders, and the construction team charges you for that extra time, charges you for the extra labor. So not only are you saving time, like in that Bell Helicopter example, but you're also changing modifications to structures or mechanical designs that are now really expensive. So it's time savings, and Bell Helicopter was great in giving HTC and Sector 5 the actual time that they saved. But it's also the fact that you're not actually cutting metal or pouring concrete or tearing concrete out to change concrete, and that's another piece of the savings.
For sure. Again, want to encourage folks to keep on chiming in with your questions. Greg, I wanted to ask what your vision is for the future. I'm not asking what's on your software development map, but it sounds like you do have a point of view about the amazing things that this technology can do. I would just love to hear a little bit more from you about what do you think the future holds.
Sure. Well, we're in the early days of really early days. Maybe even we're ahead of the early days of 5G. But Wi-Fi CloudXR works great over Wi-Fi. The problem with Wi-Fi is if you put too many users on a Wi-Fi network, you start eating bandwidth right away. You get a lot of jitter. So it's tough to run multiple users over a Wi-Fi network. So as the 5G networks become more and more commonplace, or at least start launching, we're going to see a lot of on-prem private data centers first with 5G, and you can imagine the ability to stream XR signals, AR throughout the manufacturing floor. So all the people doing manufacturing can have an AR headset on. They can see contextualized data coming into them. So the on the fly production, the JIT, just in time type of productions are going to be enabled by this massive ability to see contextual data in real time about what you're doing on the manufacturing floor, what you're doing in the surgical suite. Your designers will be able to stay off the planes, not just because there's a virus out there, but because they can have a rich interaction in where their studio is, in their home, wherever. And all this is going to be enabled by that great latency and bandwidth that 5G is going to offer. So as 5G rolls out, we're going to see these use cases really explode in how many people can get to really rich data sets and really rich collaborative environments. And so I think XR really, along with 5G, really has a chance to change the way we work and how often we can get into collaborative, creative environments with one another.
Great, thank you. We have another question coming in. Apologies, I cannot see who has asked that. That usually follows, but they do ask: Are there any plans to stream to WebXR with CloudXR?
Nothing on the roadmap yet that I have knowledge of. So we need to learn a lot more about WebXR, and there's a variety of things like WebXR out there. So CloudXR is new. We launched it early access last October, and so you can imagine we're learning a lot about the environments and what's streaming and who wants to stream to what. And so as we learn that over the next year, I think you'll see announcements coming out on the different platforms we'll support.
Terrific. Thank you so much, Greg. Anybody else? Last questions that we can ask Greg about his terrific presentation? Greg, is there anything that you want to add here at the end? Any further thoughts? Anything that occurred to you?
No, I some really good questions. I think people ask the right things, and you know, it's really what are we going to stream to? It's a pretty limited set of devices now. We'll be expanding that. We're looking for collaborators to stream to different devices. So we'd love to work with any of the manufacturers or people looking for targets for us to stream CloudXR to. And of course, any software packages that want help in engaging with CloudXR, we're certainly open to talking to them. And we just look really forward to the different interactions with the XR ecosystem we're going to have with this new streaming architecture.
Terrific. And if they wanted to get in touch with you or learn more about the product, how would they go about doing that?
Just email me, gjones@nvidia.com. And it's on the last slide of the presentation. And or jump into my LinkedIn, Greg Jones, NVIDIA should pull me up in LinkedIn. So hit me with LinkedIn or shoot me an email. Either way.
Terrific. Well, I'm going to check one more time and see if we have any further questions. Doesn't look like we do. So again, Greg, thank you so much for your time on your video and for this Q&A. Hope to see you again soon.
You bet. Thanks for having us. Yeah, appreciate it very much, AWE.
Thank you. Thank you. For our viewers, I just have a few final concluding remarks. As I mentioned previously, I wanted to have a special thanks out to the AWE's sponsors. Those include their titanium sponsors. Those include HP, Microsoft, Qualcomm, Unity Technologies, as well as their gold sponsor, PlugXR. I want to encourage folks who are still tuning in that there are other sessions still ongoing today. Please go over to the agenda and check those out. There are also VR side events. And for those who have VR headsets, you can participate in those. And we are also want to encourage people to check out the Augies on the main live stream tomorrow, starting at 11:50 PST. And then finally, thank you so much. It was great to be here with you today. Again, Laura Chadwick with the XR Association, which represents headset manufacturers. If you are a developer, we'd love to be in contact with you. Check us out at xra.org. Thanks so much, and we'll see you soon.